So I've just started recording. So this is for section, the section for week problem set number 3, categorical data. And I'm just going to quickly review the syntax. Yesterday I reviewed most of the syntax, but I'll do it again a little more quickly this time. If you look at this week's section, you might see that some of the questions are commented out a little bit. So the first thing I want to show you is this thing about commenting out syntax. You'll see that it's highlighted green here. So we can actually do, if we just highlight the code itself, notice I sort of shortened it. I do Control-Shift-C. I can actually comment it out. And that's just putting a £sign before every line. In fact, if you want to add comments of your own, you can insert comments here, and of course it'll be evaluated within the R script as syntax unless we decide to comment it. And so here I do Control-Shift-C as a keyboard shortcut, or you could do, I think I can even right click. Nope, I can't. I just do Control-Shift-C on my PC, and that will put a hashtag in front of every single line here, or £sign. And you can see that the script is always in light green. The names of strings or text variables are often in sort of a darker green. And in this case, whenever you do install packages, you want to have that in a dark green within quotes. And you'll see that RStudio, when you type, if you type interactively, it will actually autocomplete for you. You can press Tab if you want to autocomplete. And I just click Shift and then the parenthesis button, and I get 2 parenthesis signs here. And I can just type the Mosaic package here. So here I was typing it in, that command. And what I want to show you is basically that when you use the install packages function, you're installing the Mosaic package to your machine. And you only need to do that once, as I've said before. And that has to be in quotes. Now, I'm going to show you something, which is that even though we gave you script that includes Mosaic within quotes, you don't technically have to do this. Sorry. Notice I am evaluating the Mosaic package without quotes. I'm going to highlight that word and press the Shift and then quote key right next to the left of my Enter key. And you'll see that it doesn't really matter if I use the library function or the require function with or without quotes. So there's a difference between installing your package and loading your package for this immediate purpose. And in fact, after you install your package, you can actually comment it out, and then you can just load it to your local machine with or without quotes. So I emphasize getting your working directory function. You can use that here, and this will get your working directory. And then you want to actually set your working directory. And notice that's different than your working directory that you established, because here I have my working directory as my desktop. What I really want to define as my working directory is something different, which is this folder called I call pset3prob. You can call it pset3, you can call it something else. Just make sure it's pretty consistent. And in fact, I'm going to do that right here. I just press Control-Enter on my keyboard. And then you can actually use the directory function to look at the contents of your present working directory. So I want to slow down a little bit. What I'm doing here is sort of doing what I call data hygiene, which is basically putting all of your work in one place. And I want us to get into the habit of uploading data, doing the analysis, and doing it all in one location. So what I did is I got get the present working directory. Nope. Present working directory. That was a keyboard shortcut or something. And then this is define or set the working directory. So Antoine, that's why I was thinking when you had posted your question, I thought, well, having a Mac might be an issue because we actually use a different kind of path file, which is where you want to define your place on the computer. We define that differently on whether it's a Mac or a PC. So on a Macintosh computer, you'll typically have a path file that's slightly different. In fact, you'll probably do something like this: set working directory within quotes tilde users / users, and then something like name, and then desktop or something like that. That's typically sort of what you would do on a Macintosh computer. I'm going to comment it out because it doesn't make sense on my PC. But the point is that when you set your working directory, you have to set your full path file. And you want to do that every time you do your analysis. And then you sort of look at your contents of your directory. Notice what I have in my working directory on my desktop. I have problem set 3, and I have 2 files, an RData file, and then this present script that I have that I'm constantly sort of changing a little bit. And if I change it, it'll turn red, and it'll have a little asterisk here. That means that I need to save it. I press Control S, and I'm constantly saving this little script as I change it. So the point is that when you load your data, if you want to use the script to load your data, then you have to make sure that you define your working directory with the RData and the R scripts. And in fact, those are the most common 2 data files that we deal with in R. They have a suffix called RData and the script called .r. Yeah. So if you use Linux or Ubuntu or some other kind of shell command language, it should be the same working directory as a Mac. So the developers of R have made sure that basically that you can install any kind of operating system or platform. It should be. But let's see. Here I have for those of you who are interested, here's a link. I'm going to post this on this, put this in the script as a comment. Here's a link that tells you how to install R using Linux. And here's just a kind of a README document. It seems like it's the same sort of thing, though. I think you use the same relative directory. You might use CD, the CD function. Yeah, sure, of course. Right, so the main point, though, is that we want to basically put within our sandbox. I call this my sandbox whenever I do analyses, consulting or whatnot. I want to put in my sandbox my data file and my script. In more complex analyses, I'll siphon my script off, my results into a different folder or my script in a different folder. But for now, let's just keep our sandbox relatively simple. We want to define where we're located on our machine. And you'll see that here I have on the desktop, I have a file, a folder that I created where I just have an RData file and the R script. And the R script and the RData file are the 2 ones that we download each week. Okay. And this enables me to, first of all, use the directory function to define or view within the R console. This is the lower left-hand corner, what is in my directory. But also it permits me to use some of these functions that are very useful. So you can replicate your analyses. So I'm going to use the load function to load this data file. So here I just use load, and then I type within quotes the name of this data file. And you can just actually copy and paste here if you want to do this. You can copy, and then you can paste the name of the data file if you want to do it for your own analyses. Scott, one of the things you mentioned, one of our students mentioned loading other packages. You can actually use something called a foreign package if you're going to load files different than an RData file. And we'll talk about that later in the course. For now, we're just sticking with something that's very proprietary, something that is very unique, which is the fact that we're loading data basically having defined already within R its parameters. And we don't often load data that are like that. We often load data that are quite different or defined in other stat packages, for instance. And that's why I direct you to the foreign package. So here we are. This is where I want you to be whenever I do an analysis. I'm going to actually close off some of these other files here. I'm going to actually close even week 2. Well, we'll keep the week 2 code just in case. But the point is that I want you to have your week 3 code. I want you to have your data file as an object, and that'll be under the data environment. The data tab under the environment tab, I suppose. And you can see the history here, but you really want to make sure you have the environment tab located. Now, sometimes the interface looks a little different from what I'm showing you. If that's the case, you might actually have an instance where you might just have a different viewing option. And you can actually go to help, and you can go to, where did I go here? Wow, I'm not sure, but you can actually do, I think you go to view, and you can actually change, how you do the pane layouts, how you view things right here. So my default might be a little different than yours. I know for a fact that my environment, in other words, my kind of sandbox, has something called values, where I define and I show visually what it is that I've last done. Now, your environment may not show that. But the main point is that we should have our data here as a tab, and it should have this little blue thing here, this little blue arrow pointing to the right, the name of the data frame, as we call it in R, the number of observations, and the number of variables. So here we have, automatically, we know that we have 8 variables, 560 observations, and in fact, we can click this little blue arrow, and we can see that most of these are actually categorical variables. So when we talk about these variables, when we talk about categorical variables, keep in mind that factor is the word for categorical within R. And in fact, we can see that a factor variable with 2 levels has 2 definitions, male or female. Those can be assigned a number or even a character like M or F. Poverty has 2 levels, class has 2 levels, social class. Health has 2 levels, fair or good. Happiness level has 2 levels. Health, whether you disagree or agree that you're in poor health. Change, whether or not you think that health policy should change, has 2 levels as well. So the point is that we can look at much of our data set without even using the R script. In fact, if we want to click this here, we're going to mimic some of the R scripts, and we can actually view the data as a spreadsheet. Okay. So I know I spent a lot of time focusing on what is it that I want you to be, where it is that I want you to be. Mostly because, here's the point. Once we get here, if we can get to the place where we have an environment where we define where we are, where we have the scripts, where we have the data set or the data frame, then I can actually highlight all of this code right here. And I'll show you. I'm going to run this code. Here I'm running through everything. It doesn't matter. It looks like it's slowing down, maybe because I'm defining new objects as coin flips. I defined some new data sets or data frames here. You'll see that R takes its time. Okay, here I'm creating a lot of objects here. But the point is, I want to emphasize here is that when you use R script, I focus a lot more of the time on getting us to the point where we have basically a folder or location on our computer where we have both an R data script, which tells us what to do, and an R data file, which is the data set. And then we basically can run the code pretty easily. I'm going to comment some of these other bits of script out because I actually was helping other students do some other kinds of analyses. So I'm going to remove some objects. So the point is, whenever we do analyses, we can actually look at data sets, and we can also look at values. These are called vectors. But the point is that we're often defining objects with a particular label, and we can actually remove those objects from our environment. We can remove every object if we want to remove everything. In fact, we'll do this right now. I'll just show you. And that's the little broom icon. If you want to clear everything, just clean up your environment. This is pretty good practice. When you restart your analysis week to week, click on that broom, and you're going to sweep up the place. And this is called cleaning. I call it cleaning your environment. But now here's the relevant point, which is that once you clean your environment of every object, you got to load your data frame again. In fact, you probably should set your working directory just in case, because we're removing the hidden objects as well. So I'm going to highlight the syntax, and up through line, well, in my case, it's line 40, but in your case, it'll be a different number of lines. And because I commented it out using the pound symbol. And the point I want to make is that here's the virtue of writing everything in your R code, is that you can basically replicate your analysis. You can redo them. And that's so you don't have to do every, if you can use the drop-down menu, but I want us to get used to using the code. So here we are downloading our data frame, and you notice I did it one more time. So this will take us to the code. Any other questions before we get to the code? I know I'm spending a lot of time here, but I think this is relatively important. The rest of this will go pretty quickly. I assume not. Okay. So the first question our problem set asks is the number of respondents, how many variables are there. This is quite easy using these functions. And what we're doing here is because we've defined as in our environment an object called health GSS, a data frame, and you can actually scroll over this name. We'll see that it's defined as a data frame, which means that every data frame within R has something called variables, right, which are defined by the columns, and then these unique observations, which are defined by the rows. And the relevant point is that that's pretty unique for a data frame, as opposed to other things called vectors. Mostly vectors. I mean, we talk about other things like maybe character vectors, or objects more generally. And you can define anything as an object, but the point is that when we load a data frame, we automatically assign to this text health GSS, which is short for General Social Survey. We define to that bit of text what it is that we want to do with it. So here we have a data frame. We could call it X, we could call it Y. The point is that in this case, we define it as health GSS. Well, if we want to know the number of rows, and that's the number of respondents in a data set, in a data frame, we can do in rows. Now, keeping this in mind, even though I'm doing this within the script, I'm highlighting the number of columns. This will tell us the number of columns. This will tell us the number of rows. Keep in mind, I have a little shortcut for you. You know this already when you load the data frame, because within RStudio, you can just look at that bit of text right here. To the right of the data frame name, health GSS, we have the number of observations, the number of rows, and the number of columns, or the number of variables. And here we have the details on those variables. And you have the name of the variable before the colon. You have the type, whether or not it's a factor or numeric variable. And if it's a factor or categorical variable, it'll tell you the number of levels or values. And then it'll give you the actual text assignments. And then maybe some numeric numbers here or something else. And in fact, a factor variable could be, it need not have a number assigned to 1 being male or 2 being female, for instance. But the point is that there are multiple ways to do things. I want to encourage you to use the script because we can reanalyze and rerun this stuff. And we can also view it as I've done before. And then, of course, I'm going to show you a couple others. If you want to look at the dimensions of a data frame, we can also, this will give us the rows in the first part of that little object. In fact, if you notice, there's a little brackets here. This is actually an object itself, but that's beyond this. And then the second column here is the number of variables and the number of columns. So if you want to look at the dimensions, it actually gives you the rows and the columns. So the point is that you have multiple ways of actually looking at your data frame. I want us to get used to using the script. You can look at the number of rows, the number of columns, and the number of rows and columns. Okay. So now we'll look at something in terms of the probability. And if we look at question 2, the variable health measures self-reported overall health with 2 levels, good or fair. And the variable poverty measures whether one is impoverished, should be impoverished, with 2 levels, poor and non-poor. What is the probability of being poor and having fair health? What is the probability of being non-poor and having fair health? I want to show you something here, which is that when you evaluate this, the script that we provide will do something like this. Well, this is quite texty, right? In the sense that we're evaluating the probabilities to, 6 or 7 decimal places. In fact, you can actually do something like this. And this is the round function, which what we do is if you do an open parenthesis and then a close parenthesis before every command, and then do a comma 2, we're going to round our whatever we have here to 2 decimal places. Let me show this to you. So here I have the tally function unrounded, which is evaluated to, I believe it's actually to a precision of 15 decimal places, even though we show, I think that's 7, 1, 2, 3, 4, 5, 6, 7, 8. We show 8 decimal places. We don't really want to be that precise. I don't care about precision. We want to evaluate it to 2 decimal places. So what we're doing here is, this is called the nesting of functions. What we're doing is we're actually taking whatever we do here, and then round whatever we did up there to 2 decimal places. Well, this is why we have typos within script. Oh, it doesn't like the fact that I put a. I know why. It's complaining already because our object is not defined. But you notice I can insert comments wherever. Yep, you can use the options equals 2 as well. So that's a great point. So these are quite different, in fact. We can get really geeky or technical about this. If you take an odd number and round it to a decimal place that expands to an odd number, then it'll round up. If it's 0.5 blah, 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 odd, sorry, round down. If it's even, it'll round up. I believe this is sort of an agreement among scientists. Now, if you want to just change your overall display, you can do the option function. So this is this will basically, I think you can actually show your options if you do get options. Let's see, I think this will actually show us what we have. No. So, yeah, equals 2. It should be pretty much the same rounding effect. But the point is, there's something quite different than rounding as opposed to doing the options function, right? So if I do the options function, and let's see, do this, no. Oh, hold on. Then I believe what it does, no. Oh, I don't have a comma here, sorry. No. Well, the relative point that I want to make is that when you use the round, I want to encourage the rounding function because it localizes your analysis. Whenever I use the digits option, or the option, sorry, the options function, yeah, whenever I've done it, you define your whole working environments, setting it to the number of digits that you want to show. Now, in many cases, you probably want to show more digits or fewer digits. You maybe want to show more decimal places, for instance. I kind of like to keep this within the particular analysis. This is more about the style of analysis that you want to do. There you go. There's the option settings. And you control digits. Controls the number of digits to print. So the main point that I think is important here, though, is that when you round, you're actually rounding those numbers. So if you want to export that analysis to something else, then you're actually exporting the rounded numbers as opposed to the digits, which shows what it is that you were doing, but it actually still evaluates to 15 decimal places or such, as that, or 22 actually. Okay, yeah. Yep, thank you. Oh, okay. Let's try this. So Antoine just showed that if you just type this, your option equals 2. Okay. So I'm not getting that. If you type option equals 2 and you type the function, then I'm getting 7 decimal places here. 1, 2, 3, 4, 5, 6, 7, 8. So I'm not sure if that's the case. No, because what I'm doing is I'm defining as an object. So here's a little bit of a, I don't want to get too much into this, but the fact of the matter is that when I do an equal sign here, I do this thing called the assignment operator. I'm still just assigning something called option with the number 2. But let's remove that just for simplicity for now. Anyway, this is the beauty of R, in some ways maybe the vexing or more complex part of R, which is that there are many ways to do things. Regardless, let's stick to this, to the topic at hand, which is that we're analyzing health data, and we're analyzing that topically. Now, we can set margins to false, and that's what I do here. But you can also set is that we know that we're defining as a sample space each one of these joint probabilities, because each one of these values that I'm highlighting, 0.12, 0.08, 0.62, 0.19, those add up to 1. And in fact, we can look at the conditional probabilities, because 0.1 or 0.12 and 0.08 add to 0.20, 0.20, 0.62, and 0.19 add up to 0.80. And then you can look at the columns, those add up to 0.74. The relevant point is that when we talk about our sample space S, in other words, when we reinterpret categorical variables or tabulations of categorical variables in terms of probability, we want to make sure that what we're evaluating adds up to 1. And that's a very good starting point. When you want to ask yourself, well, are these joint or disjoint probabilities? Well, these are actually the joint probabilities of being non-poor and being in fair health out of the entire sample space. We know that's 12% or 0.12, because each of the combined values add up to 1, right? In fact, 0.62 plus 0.19, here we're just adding the values. This is using R as a fancy calculator. It equals 0.101, right? Here's the rounding error that we encounter often. But it's pretty close to 1, right? So we know that when we're asking you to evaluate, or when I use the term evaluate, I'm just talking about highlighting script and analyzing what we produce from the script. We're taking the round function and looking at the joint probability of being in health, good or poor health, fair or good health, excuse me, being in poor or non-poor categories. And we're showing that that's a proportion. In other words, that adds up to 1. And we're using this data that we call health GS, or general social survey. And here we set margins to false to reduce our analysis. What is the probability of being poor and fair health? What is the probability of being non-poor and having fair health? Well, those are called joint probabilities, and we know that to be the case because, first of all, in the syntax, we're using this plus sign rather than the vertical bar, right? Which is a conditional probability. And we'll talk about that later. But the point of the matter is that this is joint. This is the joint probability of the intersection between health and poverty status. So when we ask the question here, what is the probability of being poor and having fair health? Here's the probability of being poor, which is the 0.08 plus 0.19, and then probability of being in fair health. Well, the joint probability is 0.08. What's the probability? When we ask about questions of probability, we always express that as a decimal point. So here we have 0.08. Now, what is the probability of being non-poor and having fair health? Non-poor and being fair health is also pretty small in the probability space or the sample space. It's only 0.12. So, you know, being poor and having fair health is still relatively small, but it's greater for the non-poor than the poor, if you notice. This is non-poor and in fair health. 8% is poor and having fair health. 19% is poor and having good health. And most people are non-poor and in good health, or good or more, we could say. So we answered the first question. Okay. Any other questions? No? Okay. Let's get us to question 2. Oh yeah, the variable health measures self-reported health at 2 levels that are done. Oh, we did that. Okay, question 3. I'm sorry. What is the probability of having fair health given a person is poor? Now, I want to compare line by line the syntax here. What is different here? One of these is not like the others, right? I'm going to type the word false here instead of the letter F. F is the same thing as false. Well, here's the difference here. First of all, I'm going to clear the console. Now, on a PC, you can do Control L as your keyboard shortcut. That doesn't clear your history. In fact, you can see my history of the commands I've typed out. I'm going to click the Environment tab. But what it does do is it clears your console. I kind of like it. It sort of gives you a nice blank slate to work with. The main point for doing this is that we can look at the first line of scripts and just print it out. Well, look at this. Here we are printing out to 8 decimal places. Let's round again. And I'm going to round to 2 decimal places, this whatever I put in the round function. And that looks a lot cleaner, doesn't it? Because with stats, we really want to look at the overall pattern, the distribution of data. We don't want to look at any particular details. We don't want to be overly precise. We don't really care about misplaced concreteness, to sort of allude to a famous quote. We don't want to commit the fallacy of misplaced concreteness. So if we look at this text here I can show you. Actually, I'm going to evaluate everything within these 2 commands to 2 decimal places. No, it doesn't like that. It's fine. Well, it doesn't like anything I've typed here. Okay. I see why. Okay. Well, let's just try it anyway. What's going on here? I can't do this. Okay, that's fine. First, I want to round to 2 decimal places the joint probabilities. And then I'm going to round to 2 decimal places the conditional probabilities. What's the difference here? Well, let's set margins to true for the first analysis. This is for question 2. And then we'll get an idea of what's the difference between this symbol and this symbol. And I want to say, I'm going to make 2 points here. One is that order matters with the second. And also, the second measures conditional probabilities. What does that mean? Well, and then the first, joint probabilities. Probabilities. Okay. I'm going to highlight this and Control-Shift-C, and I'll just put the hashtag in front of there. So the point is that if we actually set margins to true for both of these commands and just isolate the fact that only thing we're changing is this little operator here, and an operator is anything that you can use to concatenate things like a minus symbol or this thing called a pipe. The point is that order doesn't matter for here, but it does matter when you look at conditional probabilities. And I hope this will be the clearest exposition of the difference between joint and conditional probabilities. What's the difference between the top output and the bottom? Are these the same analyses? Anyone? Are they the same? Let me try to throw a bone your way, which is that if you in these middle values, given that we know you're some poverty status, but it doesn't Hello? I'm sorry. I think I got disconnected. Can you hear me? Hello?
Well, I can hear you, but I can't see you.
Hello?
Hello?
Ah, okay. I'm sorry. Somehow I had an internet foul up. So for a few seconds. Okay. Now can you guys see it? You guys should be able to see RStudio. It's been breaking. Oh, I didn't know. Oh, shoot. Well, I'm sorry about that, guys. That'll affect the recording quality. Can you guys hear me at least?
Well, now.
Yeah. Okay, unmute you guys, right?
Okay.
Yep. Okay. Sorry about that, guys. Oh.
Yeah, I think you can hear me again, right?
Well, I can hear you. This is Anton?
Yeah, Scott here.
Scott? All right, this is Denzel. I can hear you.
Yep. Oh, sorry about that. Yep. Sorry about that, guys. So
Okay.
how far did we get? Did we get to the, where did I lose you guys?
We were kind of talking about the difference in the margins. You were asking us to see if we could see the difference between the joint or the conditional
probability.
Yeah.
Okay. Yeah. So I lost about 3-4 minutes there. Sorry about that, guys. Or maybe less. I'm not sure. But the point is that if we look at conditional probability, order matters. So if we look at this as an equation, this is called the equation format of syntax. We want to say, I want to tally health given that I know poverty status. So what you know is to the right of that pipe symbol. What you don't know or want to find out, given what you know, is to the left of the vertical bar symbol or the pipe symbol. And the name of that I'm using is pipe, P-I-P-E, or vertical bar. And that's an operator because we're basically saying, I want to take this variable and this variable and get some sort of outcome here. And here, what we're showing is that you know that you're defining your analysis differently because here we have your probability space being different, 0.7. So what we're saying is we basically siphon off all those people who are poor, then you look at your health, your probability of being in poor or good health. Then we siphon off all those non-poor people, and we look at your probability of being in health. And each of those are different probability spaces at the intersection of those two. And I think setting your margins to true lets you see that a little more clearly because here in the above, you look at, for question number 2, you can see that everything in those values adds up to a fractional value of 0.1, but everything adds up to 0.1. So the columns add up to 0.1, the columns add up to 0.1, the rows add up to 0.1, and in particular, the individual values add up to 1. As opposed to what we're doing here is we're defining first the columns, and then we're looking at your probability given those columns. Does that make sense? It's a pretty intuitive case, but I think there's more to talk about here, right? There's quite a bit to talk about when you talk about scripting like this because, I wanted to show you. When you look at joint probabilities, I mentioned this point a couple times, order doesn't matter, right? Why? Because, I don't know, it doesn't here. So this analysis here is different than this analysis here. I mean, you can look at these marginal values are swapped, right? So here we're looking at the rows and columns. But the point is that the joint probability, the intersection of two values, it doesn't matter whether we define A versus before B. When we look at conditional probabilities, order matters, both in the syntax and in the interpretation. And you want to put to the right of the pipe what it is you know. And then you want to define your probability after that. So the question for the 3 is, what is the probability of having fair health given a person is non-poor, or sorry, what is the probability of having fair health given the person is poor, given, and then what's the probability of having fair health given the person is non-poor? Well, as long as we use the conditional probability function, you can actually see the probability of being fair health given the person is poor is 0.3, and the probability that the person is in fair health given that they're non-poor is 0.16. Okay. Any questions about conditional or unconditional probabilities or joint probabilities? Both in syntax and in terms of analyses? No? Okay. Good. Now we can go on to relative risk. Okay, I kind of like this. Mostly because it's so common within epidemiology. I think it's extremely useful. So hold on for a second. I want to show in the syntax here the relative risk of something being true. And notice that what we're doing here is, well, first of all, my question would be, well, how do we find out relative risk, right? Well, I'm going to show, I think, what I hope to be a relatively simple way. So keep in mind that when you think about relative risk, you want to define RR equal, hold on. I just want to be sure that we're defining risks. So, right. So relative risk is the probability of B over the probability exposure rate. So, we want to look at the conditional probability given a person is in one category as opposed to conditional probability of the person. So what is the relative risk of having fair health? In this case, I want to show you can actually do it a couple ways. You can actually use the joint probability table. If we use a plus sign here, I'm going to clear the screen. You can also use a conditional probability. The conditional probability is a little bit easier, but this will be useful for the final exam. So we know that right. So the first point that I want to make clear is that when we do the joint probability, we look at relative risk. We really are interested in right. So you want to basically look at the joint probability of being in non-poor and in fair health. So relative risk we'll define as actually probability of fair and non-poor. We're going to define as this value, and then we're going to define, get that here, and then we're going to define as fair and good health. We're going to assign, fair and good health. We're going to assign with this value, 0.84, 0.84. And we're going to define as relative risk, or the conditional probability, conditional fair as, as the fair and non-poor, probability of being fair and non-poor, divided by probability of fair and good plus probability of fair and non-poor. Although, hold on for a second. Yeah, sorry. I got my value, I got the names of my objects confused. Hold on for a second. You want to do, sorry. non-poor and good. That's how you want to define it, sorry. All I'm doing is actually just showing you sort of how basically how the analysis works, which is what I'm doing here is I'm assigning to a particular numeric value or a scalar 0.16 to being in the probability space, or having the probability of being non-poor and in fair health, and the probability of being in good health. And what we're going to find is the conditional probability of being, given that the probability of being in non-poor, what is the probability of the outcome? Hold on, yeah. Sorry, given that the person is non-poor, what is the probability of being in fair health? It's just simply the ratio of being in fair health as opposed to being an entire group of the non-poor people. And you see that is, well, hold on for a second. That makes sense? Yeah, that should work. I want to order these so that they make a little more sense though. Probability of good, non-poor. Hold on. If we define our objects this way, and then we can print this, we can actually use the print function here, or we can just actually type out the object here if we want to print it. Conditional.fair. That's 0.16. And what we're doing here is we're just taking everything that we define in our sample space in the conditional probability space and dividing it by that. So of course, that's 0.16 divided by 1. Okay, well, that's a little academic, right? Well, it's not very useful. Well, it's more useful if you want to look at the joint probability table. So if we want to define this as joint probability, taking the ratio would make more sense. So we take 0.12 divided by 0.62, 62, sorry, 0.12 divided by 0.62. Oh, sorry. And then you can do the conditional probability of fair. It's 0.16. And if you go up, that's basically the same value that we had before. So here I basically showed with joint probabilities the same thing, regardless if you do joint or conditional probabilities. Now, why am I going through all this effort just to show that we're ratios for conditional probabilities? Because that's what we're doing with probabilities. We're looking at, given that you're in this sample space, you have this value. What is the probability of being in this category in fair health? And in fact, that's what the relative risk is. So we have the conditional probability of being in fair health, and then the conditional probability of being in good health, which is fair. Right. So we have the probability of A and B divided by the probability of B. So we basically have right. So what's the probability of good, being in good health? Hold on. Being in good health given that you're poor or non-poor. Oh, right. So the main point here is I just want to show quickly that even though we have conditional probabilities here, I can show them as a ratio. And if you just want to know what is the relative risk, it's actually relatively simple here. You can basically take the value of one divided by the value of the other. I want to make sure that we have the ratio correct. Yep. Of being in fair health. Yeah. Here we have the value of 1.88, which basically means that being, given that we know what poverty status you are in. So in other words, what I just basically did here is I take the conditional probability of one value and take it by the conditional value of being in another category. So if we want to do being fair versus poor, should define this as fair poor, non-poor. That would make more sense. That's all we're doing here when we talk about relative risk. And the relative risk would be the ratio of conditional fair poor divided by conditional fair non-poor. In fact, that's all we're doing here. So I'm making sort of a fancy analysis here, where we don't have to do too much here. In fact, all we're doing is we're just taking the ratio of the conditional probabilities, and all we're showing here is that the relative risk, given that we're poor, we know your poverty status, what is the relative risk, right, versus one category to the other? What is the relative risk of being impoverished? And we know that, in fair health. And we know that here, the data show that your poverty status almost doubles your risk of poverty. And we know this because this is how we interpret relative risk. Like a lot of things, it is always relative. That's a really key point here. It's not a truism, because what we're doing is we're multiplying our risk by some value. So we take our risk and multiply it by our value of our R. So all we're saying is if your risk is, say, 1%, 2%, then your risk of being in that group, given an RR value of 0.185, is 88 rather, times the prevalence in our category. So in our low risk group, we sort of say, well, to clarify, all relative risk does is it shows you how much does your probability increase given you're in the exposure group. In other words, you're in the poverty status group as opposed to the non-poverty status group. So again, it's a little bit of a truism here, but like a lot of things, it matters. Does that sort of clarify things for you guys? I hope. Oh, I'm sorry. You guys are having trouble hearing me? Having trouble hearing me?
I can hear you pretty good. Okay.
Let me stop my video. I'll stop my video. Okay. I can also see if I can improve my... here, guys. This will work. I'll use the Ethernet. Is this better?
So far, it sounds pretty good.
Okay, good. The main point is, did you guys get the answer for relative risk? Does that make sense a little bit? We're just taking the ratio of conditional probabilities?
Yep. Yep.
Okay. So we know that living in poverty increases the risk of being in fair health as opposed to good health. And in fact, being in poverty increases the relative risk 1.88 times of being in fair health as opposed to good, whether you're in poor versus non-poor. And we know that because about 30% of people are who are poor are in fair health as opposed to 16% of those who are non-poor and in fair health. So we know that you double 16%, you're going to get about 30%. Okay, we're going to ask a lot of questions about relative risk. Okay. Now this was a little bit of, I guess, ambiguous in the problem set. So we're actually going to give credit for you guys on this one, because it's mea culpa. It's our fault on this one. The variable change, actually, if you look at the value, and I'll go to the script here, or sorry, go to the view here. Change value of yes means yes, you do want the health system to be reformed. A value of no means you don't want it to be reformed. I believe the question was overly ambiguous here. Yeah, I think it's a little clear here, but it wasn't very well worded in the problem set. In any case, what is the probability of wanting to change the healthcare system? Responding yes. Among those who are poor, how about those who are non-poor? What do the findings suggest? Let's round this. This is another case where rounding really helps. Let's do a close parenthesis on this. And what does it suggest? Well, if you look at those who want to change versus who who don't want to change, what do the findings suggest here? So what this suggests actually is it suggests consensus. Whether a person is poor or non-poor, your probability of saying yes or no is the same. In fact, it has, what's the relative risk here? Well, the RR here would simply be 0.31 divided by 0.31. And a relative risk of 1 means that there's no increase in risk. So this is a good example of how to understand relative risk. A relative risk above 1 means an increased risk relative in your exposure group versus the not exposed group. Relative risk of 1 means that there's a consensus or there's no risk. In other words, being poor or non-poor does not change your views on what healthcare system we should have. All right. Any other questions about maybe examining the data, and in particular, looking at this thing called relative risk or conditional probabilities or joint probabilities?
There was one tip that you gave, which was kind of when the audio was breaking up, and I'm wondering if you could just say it again.
Sure.
When we were looking at the conditional code, you mentioned to the left of the pipe is something, and to the right of the pipe it has something.
Sorry about that, Scott. So yeah, so to the left of the pipe is what it is you want to know. Okay. To the right is what it is that you know. So this is the equation formula. If you look at like something called, I think, the LM function. This is a classic example of the formula. So you could sort of say the formula function, which is that when you have this tilde here, this is kind of like an equal sign in an equation in a way. Okay. I know this is maybe a little off topic because y equals mx plus b. This is basic algebra, right? You could sort of say our outcome, what is it that we want to know, is our health, but we know this. And that's how we define as what we know. And this is where order matters. This is what I was saying before, which is that the right, we want to define as our conditional probability. And when we think about relative risk, to the right of the pipe is our exposure or non-exposure group. So it's our risk factor. Here we're talking about poverty status consistently, but you may want to think about other things like, I don't know, age is a risk factor. You know, in this data set, we could look at class. You know, if you have a project you want to look at, we could even look at sex as a risk factor, being male or female. And here we look at this, and then we can look at the relative risk of being in fair or good health, whether you're male versus female. Here the relative risk would simply be, well, it depends on how you define it, but if you want to look at the relative risk of being male, they're less likely to be in fair health, actually, in this data set. So what's the relative risk? Yeah, it's less than 1. And that's how we interpret a relative risk less than 1, actually, is that you're less likely to be in the risk group. So this is a clear example of how conditional probabilities help us inform or understand relative risk, and how also I wanted to illustrate the differences and the similarities between conditional probabilities and unconditional probabilities or joint probabilities. But the order matters here. Conditional is simply saying conditioned on what? When you ever hear conditional probability, I want your ears to perk up and you to think conditional on what? Well, here we're conditional on typically on poverty status, but it could be on anything else.
Okay.
Right. Does that make sense?
Yeah, definitely.
Right, cool. Awesome. Okay. Any other questions you guys have? No? All right. Well,